Hey math fans, welcome to the Chapter 10 Section 2 notes over measuring angles and arcs. Just a little information at the top. I have these notes filled out ahead of time just to keep this video nice and short, but I will explain to you how I got everything, okay? So the first thing I want to start off with is the central angle definition. A central angle of a circle is an angle with a vertex in the center of the circle. Its sides contain two radii of the circle. So in this image right here, triangle ABC is a central angle of circle B. And then of course, if you think about it, if you go full circle, you travel 360 degrees. So that's what this property is saying right here, is that the sum of all the central angles in a circle add up to 360 degrees. Next, we got to talk about arcs. An arc is a portion of a circle defined by two endpoints. A central angle separates the circle into two arcs with measures related to the measure of the central angle. So when it's talking about arcs, if that sounded confusing, this would be like arc AB, this would be arc ADB, this would be arc ADB. Okay, so the arcs are like the outside of the circle, and the central angle is coming from inside the circle. You're going to have three types of arcs. You're going to have a minor arc, that's any arc that's less than 180 degrees. A major arc will be more than 180 degrees, and then a semicircle will be exactly 180 degrees. So for my first example here, I'm looking for angle GFJ or X, and so I know that all the sum of the degrees is 360, so I'm going to subtract out what I know. I'm going to subtract out 130 and 90, and that'll find X, which is 140 degrees. This example looks a bit more complicated, but what's going on is I have this picture right here, and I'm given some piece of information about all the angle sectors except for this one right here, QTR. And so what I did was I just cut this circle in half. If you look, if I erase my line, you'll see that this is a line that is perfectly going down the middle of the circle, creating a semicircle. And so what I'm going to do is I'm just going to add up these three sectors and set them equal to 180 degrees. So I'll add 8x minus 4 plus 13x minus 3 plus 5x plus 5, and I'll equal it to 180. So here's my work right here. I'm going to combine all my x terms. 8x plus 13x, that's 21x, plus 5x, that's 26x. Then I have negative 4 minus 3, that's negative 7, plus 5, that's going to make negative 2. So I have 26x minus 2 equals 180. So I can add 2 to the other side and then divide by 26, and I'm going to get x equal to 7. So that answered the question of find the value for x. However, what I chose to do was plug it back in to figure out all these missing angles. So that's why the problem looks so busy right here. So I plugged it in. The 8x minus 4, 8 times 7 minus 4 is 52. 5x plus 5, that one's 5 times 7 plus 5, right? So that's 40 degrees. And then 13 times 7 minus 3, that's going to give me 88 degrees. 20 times 7, that's 140 degrees. And so I figured out everything that had an x with it. And so what I did was I just added these all up and I took them away from 360. And so the one with no information or no x term at all in it, the question mark angle, that one's going to be just 40 degrees when you take all those away from 360. In my next example, I have that GJ is a diameter of circle K. So identify each arc as a major arc, minor arc, or semicircle, then find its measure. So I'm looking for measure of arc GH, and I wrote that's a minor arc that's equal to 122 degrees. So here's GH. You can see that it has 122 written right there, so that's why I knew it was 122 degrees. And so if it's less than 180, that's a minor arc. For GLH, I said that was a major arc, and I said it's 238 degrees. I did 360 minus 122 to get that. So let's look at GLH. GL, and then it's going to skip over J, so technically that means it's including it. So it's going to go GL all the way to H. So it's the whole circle without the 122. That's why I did 360 minus 122 to get 238. And so because that's more than 180 degrees, that's a major arc. And then GLJ I wrote was a semicircle, so semicircles are 180 degrees. So here's GLJ. You can see it clearly make a semicircle right there. Alright, in example 3a, I wrote find each measure in circle F. So measure of arc AD, that's going to be a minor arc. If you look, AD is going to encompass the 63 degrees and this 90 degrees because it's going to go A through E all the way to D. So just add those two together, you get 153 degrees. Measure of arc CBA, so C to B to A, if you look, that makes a semicircle, so that's just 180 degrees. Okay, so for example 3b, the first thing I'm going to look for is measure of arc LI and circle M. So if you trace it, LI is this right here. And what is it directly next to? Or it's adjacent to IMJ, and that's a 90 degree angle right there. So therefore IML must be a 90 degree angle, so LI is also going to be a 90 degree angle. Also, you could tell that LJ makes is a diameter, so that's going to make a semicircle. So if you did 180 minus 90, you'd get 90, and then minus 32, you'd get this as 58. So 58 minus 32 would also equal 90. For IK, measure of arc IK, that is encompassing this 90 degrees and whatever this is. It is a vertical angle with this, but you don't necessarily know that for sure. So what I did was I figured out arc JK, and I did 180 minus 90 minus 32. So JK is right here, and what I did was I drew a semicircle with this line, HK. That's also a diameter. So I did 180 minus 32 minus 90, and that gave me 58 degrees right here. Since I'm looking for IK, I just do 90 plus 58. And so 90 plus 58 is 148 degrees, making this a minor arc. So now we're going to talk about something called arc length. By arc length, we're not talking about degrees, we're talking about like a physical measurement. Like if you were to take the circumference of a circle, that's the length of a whole circle. So an arc length is just the length of a section of that circle. So it is going to use the circumference of a circle formula. You're just going to, it's going to be proportional to whatever degree you're given for the sector. So whatever degree you have in here, you'll put that over 360, and then you'll multiply that by the circumference of a circle, which is 2 pi r. Okay? So in this example, and all three of my examples, I'm finding the arc length of zy. So in example A here, I have a radius of 4, and I have an arc of 75 degrees. So I'm going to do 75 over 360 times 2 pi r, so times 2 times pi times 4, which was my radius. And I just typed all that into the calculator, and I got about 5.236 inches. So that's how long this is right there. For B, I'm given 10 as a diameter, so therefore my radius must be 5. So I'm going to do 130 over 360 times 2 pi r, 2 times pi times 5. Or you could just say 130 over 360 times 10 pi, because you know the circumference is 2 pi r, or pi times d for pi times diameter. Either way, you're going to get approximately 11.345 centimeters. And on my final example here, we're going to have to work backwards. I'm given the arc length as 4.19 inches. So therefore, it's going to say 4.19 equals, and then just plug in everything you know. I know that this is 40 degrees, so I'm going to do 40 over 360 times 2 pi r. So really what I don't know is the radius. I don't know what zx or zy is. So divide everything out that you know. Divide 40 over 360 and 2 pi to the other side, and basically you just type all this into your calculator. I recommend using the Desmo Scientific Calculator, that way you can see how everything looks when you're typing it in. But I would basically do like a big set of parentheses for the denominator, so that way you make sure you type it in correctly. So I have 4.19 on top of 40 over 360 times 2 pi, and that'll get me approximately 6.002 inches. So that's it for my examples. Thank you for watching. I hope you learned something, and goodbye.